So what exactly is population? When we think of population, we usually imagine cities such as Toronto with a population of 2.7 million or New York with a population of 8.3 million. And we know that population is much more than just humans. Population size is the number of all organisms of the same group or species which live in a particular geographical area. We can represent this number with a variable n. So how do we actually go about solving for n? Well, it's really simple. We just have to go out and count the number of species that live within the area. But sometimes finding the population size can be a challenge. For example, if you wanted to find the population size of squirrels that live in the Greater Toronto Area, it would take some time to count each squirrel one by one. This brings us to our next calculation of population density, or DP. Population density can be represented by the equation n over a, where n is the total population size and a is of course the study area. Population density is extremely useful for being able to estimate the population of a specific species in a larger area. Instead of determining the number of species within the total area, we can simply find the population density within a small section and then multiply by the total area, because population density is simply a measure of population size per unit area. Let's start off with an easy one. Suppose some students want to calculate the population density of Toronto. They look at recent census results and find that the population of Toronto is currently at 2,731,571 people. Next, they find that the total area of which these people reside in is 630.2 square kilometers. How do you find the population density of the city of Toronto? Okay, so you were given n, which is 2,731,571 people, and you are also given a, which is 630.2 square kilometers. Now you can simply plug it into the equation that we were given earlier, dp is equal to n over a, and you get your equation for population density, which is 4,834.5 people per square kilometer. Now remember that the units are always very important, you should never leave them out. Okay, so now let's do our next calculation, which is a little more challenging. So ecologists are sampling the distribution of pine trees in the Black Forest of Germany. The forest has a total area of 6,009 square kilometers. The ecologists place 4 1 kilometer by 1 kilometer quadrants randomly within the study area. The number of pine trees found in each study area is 1,250, 890, 1,000, and 960 respectively. What is the population density of pine trees in the Black Forest? And also, how many pine trees are located within the Black Forest? So how do we go about solving this question now that it is slightly different? Well, we can start off in the same way with our equation dp is equal to n over a. But now n, instead of being the total population size, is now just the sum of all the populations that we found in each of our 4 quadrants. And now a is also changed to just the number of quadrants times the size of each quadrant, which is in our case 4 times 1 square kilometer, because all our quadrants are of the same size. And through this we can find our estimated population density of 1,025 trees per square kilometer. Now remember, this is just an estimate as we did not sample the entire population. So that answers the first part of our question. So the second part is, how do we find the total number of trees in the Black Forest? Well, we could use the same equation, just rearrange a bit and solve for n. So now we can multiply our estimated population density by our total study area, which is 6,009 square kilometers. This gives us a whopping total of 6,159,225 trees in the Black Forest. Another method used to measure the population size is called the mark and recapture method. So basically the mark and recapture method is where the species is captured and marked with a collar band or tag, and then later released into the wild. And then later, after a while, they are recaptured and used to determine the population size. They do this by the equation summarized by population size is equal to the number of originally marked multiplied by the total of individuals in recapture divided by the marked individuals in recapture. So, if 45 pigeons were captured and marked, then 1 week later, 45 more pigeons were captured, and out of those 45 pigeons, 15 were already marked. What is the estimated population size of pigeons? So, how do we approach this problem? Well, we can just use our equation that we were given previously, where n is equal to the number of originally marked times the total individuals in recapture divided by the marked individuals in recapture. So now we can just plug in our numbers. So the number originally marked is 45 times another 45 in recapture, then divide by the 15 who are already marked. So this, we are given the n value of 135. So therefore, an estimated population of 135 pigeons. So the mark and recapture method is especially useful for highly mobile populations, such as fish or birds, because it's really hard for scientists to count the number in their population if they're always moving.